This is the ROS Developers Podcast, episode 120.
The ROS Developers Podcast, the ROS Developers. The ROS Developers Podcast, the ROS Developers.
Hello, ROS developers, and welcome to the ROS Developers Podcast, the podcast that give you insights from the experts about how to program your robots with ROS. This is Ricardo from The Construct, and today I would like to dedicate to all those roboticists out there that are working hard in order to bring robots into space. So you are working with your robots that are going to land into the moon or maybe even beyond into Mars, do excavations, prepare the environment for us. So if you are one of those, you are one of those lucky ones that are working on this episode is dedicated to you. And today we are going to learn more about using ROS for space. But before going into that, let me tell you that in case that you would like to learn ROS and then start developing your own space robots for the future, then you have to go to the Construct and learn everything that you need for programming robots with ROS. At the Construct, we provide online training, which is based on simulations and real robots, remote real robots. So our courses are not based on watching a video and taking your notes, but instead of practicing from minute number one with a simulated robot that appears on your screen. And when you are progressing on those simulations, then you will connect to our remote robots that we have here in Barcelona from wherever you are, and then you will be programming our robots remotely, and your programs will be executed here. You can see some cameras that will give you what the robot is actually doing based on your commands and so on. So if you want to be programming the robots of the future, you need to learn ROS, and no other best place to learn about ROS than at the Construct. Check on the show notes for a link about how to learn more about ROS at the Construct. Okay, and now let's go to the meat of the episode. Let me introduce you Will Chambers. Will was the principal technologist in AI and robotics at Blue Origin, you know, the company of space robotics of Amazon. And there he cooperated to found the Space Robot Operating System together with NASA and with Open Robotics. At present, Will works at Peraton as a senior director in Algorithmic Operations, AI, and Autonomy. And he is a member of the Space Robot Operating System Technical Steering Committee. Welcome to the podcast, Will.
Hey, thanks for having me, Ricardo.
My pleasure.
You know, I had Elvis dancing to your jingle at the beginning there.
Yes, we couldn't see it because I was occupying the camera.
Yeah, so now that we got the camera, there's Elvis dancing to the jingle.
Oh, okay, yeah. So it's switching. Right. I think the camera is switching to the noise here. So, well, we saw it a little bit, Elvis, with the song of the podcast. So nice that you brought it.
Yeah, he says thank you very much.
Okay. My pleasure. And, well, I was very interested to interview you because that Space ROS is something that a little bit mysterious, that it appears from nowhere, and then the audience wants to know more about it. So what can you tell us about what is a Space ROS and what is its purpose?
Yeah, I mean, so, you know, the one-liner is that, you know, Space ROS is a software framework for, you know, flight quality robotic software, you know. And so, you know, what that means is that in order to put robots in space to operate certain classes of missions, high risk profile class missions, you need to have certain kind of mission and safety assurance in the software so that the mission can be completed. Because these are, literally some $1 billion missions that might be on Mars for years. And you want to ensure that you're not going to have some exception handling that's going to stop an operation or buffer overflows. That are
Segmentation fault.
Yeah, segmentation fault. You got it, right? So in the past, ROS has been used in space. So ROS in space is not new. But those missions were things like, Astro Beam or the Robonaut. They were lower risk experimental missions in controlled environments inside the a space station, with humans there to handle any type of fault or failure. So it was really a low risk situation. The impetus for Space ROS is that we have Artemis, we have a lot more future and planned presence in space. So let's have a reusable modular software framework that a community can contribute to and use, bring down the cost of robotic software because of its accessibility, because of its reusability, so that we can begin executing some of these riskier missions that you alluded to, like on the lunar surface for construction, assembly, mining of asteroids eventually, in space on orbit operations far away from Earth in geo or cislunar space.
Wow, awesome. But then the question is, why can't we use regular ROS2 for robots in space?
Yeah, we've alluded to some of it already. I mean, if one looks at the software of ROS2 right now, you have C++, you have Python, you have Java. It's not consistent, it's not homogeneous, and it's not easy to ensure that all that software is safe. So firstly, you need to strip it to a type of software that you can use in high-risk space operations, which means C++ essentially.
Okay.
And we use C++14. So why is that? Well, it turns out that most of the tools for checking for like static analysis and for the type of flight quality rules that we want to enforce assume C++14. So it's a good place to start, first of all. And then, it's a robust, low level, or type of language where you can understand what's happening in memory. You can control, you have a lot more control over execution and memory and the type of things that you want to ensure in these type of systems.
Okay, yeah, but then still, I don't know why we can't use ROS2, because ROS2 is you can, if you want, you can enforce all the developers to write the code in C++. So done, C++. So what is preventing from using ROS2 as it is? So my question is, why do we have to do a Space ROS instead of using just plain ROS2 directly?
Yes, yeah. I mean, one could, but there's certain rules like an AutoSAR, MISRA, JPL, power of 10, certain specific type of rules that need to be enforced in the code. So essentially, what we're doing with Space ROS is doing what you're saying for the most part. Like, we're taking ROS2, we've developed this continuous qualification system where we can run ROS2 through this system, do static analysis with some specific tools that were developed by NASA and others. Generate generate files that capture things that need to be corrected in order to reach flight quality software. So now we have artifacts that we can generate that point to the software going through a process that allows it to be approved for flight. So we're generating also artifacts that align to flight certification standards. So, for example, there's standards, a DO 178C for aerospace, like planes, software needs to subscribe to. NASA has 7150.2. There's certain rules that they define. Software shall follow these rules. So what we're really doing is structuring and making a process that you can track that indeed this ROS software has gone through this process. Here's the proof that it's gone through the process. So now we have the artifacts to demonstrate that it's flight quality. In addition, like with ROS, although it's not like it's more of an adopted de facto standard. Use data distribution services as a message passing. Well, a lot of flight systems don't use data DDS. They use different type of message passing. So we also need to align to that or build bridges to some of these other frameworks, like core flight system. Now you can do that with ROS 2, and once you do that with ROS 2, you're basically getting to Space ROS. I mean, that's the idea, is just take ROS 2 and adapt it, adjust it so that it can be used for flight. It's still ROS 2. It's like hardened ROS 2.
Yes. Okay. Now I understand. So then can we say, for example, if I have correctly understood, that Space ROS is like ROS 2, in which the communication system is not DDS, but another one, which is the standard that you use at NASA. And then also with all those tools that provide this static analysis of the code and those artifacts that ensure that the code that has written is following the standards. So that would be Space ROS?
Yeah, that is the correct way to assess it. We start with the standards. We start with DO718C, NASA NPR 7150.2. A lot of numbers to remember there. Some companies, lean towards one, and some companies or organizations lean toward the other. And then we have a cross-compliance matrix. So we can basically say, all right, just take both those standards, deductively, this is what the software should subscribe to. So let's define the rules that enforce these requirements for these standards. And let's have a process that we can take the code and run it through to make sure we're subscribing to those rules and that we're generating the artifacts that prove that indeed we have addressed those rules.
Those ones. Okay.
In addition, we have a different message passing type of interface, as you alluded to, for so that we can interoperate with some spacecraft or other message passing frameworks. And then lastly, if we start looking at a package level, there's certain capabilities you want in space for localization. Like, let's say you want a star tracker, right? Well, we need to have a star tracker that's predicated in Space ROS. But first, we're going to start with Space ROS, so that we call this the iceberg model. Whatever we're building on top of is already flight quality software, and then we're going to start building on top of it. That's the picture eventually. Right.
Okay.
So there's other applications that are space specific as well.
Okay. Now I think I understood the idea. And then let me see here my questions. So then when we say that it is a certified system, so Space ROS is a certified system, is because it has all those artifacts that demonstrate that they have passed this matrix of requirements that you mentioned before.
Yeah, it's really not so much certifiable. It's 60% there. So we're getting the developers at an organization a head start on qualification. That organization still is, has the impetus. It's on them to prove that for the mission, in terms of behaviors of the system, they still have to go through verification and validation and prove to their customer or to themselves that the software aligns to the standards that organization has adopted, to the requirements, I should say, that organization has adopted. But what we're doing is getting it 60% there with the core base to start from.
Okay.
We do provide some formal methods for verification and validation. We have a tool called FRET that was developed by NASA that we include. There's another one. Let's see here. Doorstep is the name of another one that we use for formal verification and validation. And what that means is that once we start building on top of Space ROS, let's say we're building manipulation, you still have to go through the requirements trace of a manipulation mission that you're able to, let's say, grab another spacecraft without imparting too much momentum onto it. Right? You need to verify it all the way from that level of behavior down to the lowest level of the code behavior. And so we're kind of like the under the water of the iceberg is what Space ROS is addressing.
Okay, and then when you mentioned about the status of the current implementation of a Space ROS is, so if I have correctly understood, you are still developing this base of adapting what ROS2 is providing already into this quality of quality required for space missions, and then once you have that, then you will start building applications on top of using maybe some other applications that you already have for regular non-ROS vehicles, like you mentioned the localization system based on stars, if I have correctly understood.
Right.
Okay.
Yeah. So that's essentially correct. I mean, so we have. You were mentioning the initial partnership, so perhaps I should address some of the history. While at Blue, we started Space Robot Operating System as part of a program called an ACO, Announcement of Collaborative Opportunity, with 3 NASA centers, and that was the Ames Research Center, Goddard Space Flight Center, and Johnson Space Center. So it's three centers that deal with robotics and understand some software. And later on, as a subcontractor, we brought on Open Source Robotics Foundation so that we could start leaning on the infrastructure and their knowledge and some of their developers to help accelerate the project. It was a 2-year project. It started 2022, essentially just ended in January of this year or December of last year, that ACO. At the end of that ACO, we had the foundations, the infrastructure established for continuous qualification. We began maturing that code that's under the iceberg. I'll put my hands up here so you can see, under the iceberg. And, we have a GitHub that has the code. It has Docker images. We have a space.ros.org website one can go to get questions answered. So we really focused on the foundations so that at the end of the ACO, we can transition to an open community.
Okay.
Now we're at that point, and Open Source Robotics Foundations is still the steward of Space ROS. And we have the beginning of a technical steering committee with leaders and some members. And now it's to the next step is now we can accelerate the maturation, really define a roadmap and start beginning accelerating the maturation with the help of an entire open community. All right, having said that, one can still mature, let's say, in ROS too, because we want to keep the APIs pretty much compatible between Space ROS and ROS 2. One can develop space, let's say, manipulation applications using MoveIt or something like that. And eventually, you should be good enough that you can just kind of port it to Space ROS without too much extra effort.
Yeah,
so you can. Yeah, so you could take that application and run it through our continuous qualification, run it through our static code analysis, or lean on the transform functions that are Space ROS, like the TF type of libraries that we've already matured through Space ROS. Just kind of backward port it. So there's no reason why it's not ideal. It's just how it is right now. There's no reason why one couldn't work in parallel and then kind of dovetail, later.
Okay. Yeah, because that was my next question. It's about, so you are mentioning that all the applications that run in space, they have to have this kind of high quality standard. And then, so my question is, so then why to use ROS2 in this space robot operation system if one of the main advantages of using ROS is that there is a lot of software already out there that you can use off the shelf with any robot that you don't load. But if you have to make all this port of your applications into the Space ROS, then once you have the basic structure of ROS2 for space, then any other application that already exists needs to be also to be ported, right? For example, MoveIt that you mentioned. MoveIt has to be, let's say, ported into a Space ROS. And any application that uses MoveIt also will have to, right? Have I understood correctly?
Yeah, and that's true. And the alternative is that I don't want to pick on MoveIt in particular, but MoveIt or Nav2 or any other package, in order to be used in space in these type of missions, would still have to go through that type of requirements, verification and validation, regardless. So one's not going to pick up Nav2 and use it on the moon. It's just not going to happen. Oh. At least for NASA. Like NASA would not allow it. Now you do have like the Viper mission where they're using ROS, but it's using a lot of it on the ground. And there's been some smart people who are doing some safety and mission assurance checks on that software, because this is a very important and high valued mission. So regardless, for high risk missions, regardless of the software one's putting up there, it has to go through these these safety and mission assurance checks.
I see.
So what we want to do with Space ROS, it's like what you're mentioning here. We want to start building out this open source framework so that there is a space nav that exists.
Ah, I see.
MoveIt that exists, that's predicated on Space ROS. That's accessible because it's open source. It's modular. It's reusable. It can be run real time is another difference that I didn't quite mention before. We're looking at RTEMs. We've shown that we can run Space ROS on RTEMs. So we want to do a lot of the heavy lifting for the space community, because there's this beautiful dream of being sustainable in space, and to have a permanence, or at least a long-term sustained duration, the presence in space. And that's going to require robots, and that's going to require robotic software that's robust to those missions, right?
Okay, got it. Now I understood the whole picture. Yes. Okay. Yeah, of course, there is a lot of work to be done in front. Yes, of course. But once this is done, then is when the whole space community can take profit of it, because there will be this framework for all the applications, and for all the applications that have followed the procedure to adapt to Space ROS, then they will be available to anyone and to all the robots in space, already certified with the quality that is required for a critical mission.
You got it, Ricardo. And
Okay.
I tell you, like when we were formulating Space ROS, this is software, and we started advertising it to potential users or customers, there was no criticism. It was, oh great, someone's developing space robotic software, because most space robotic companies are focused on the hardware. That's really like where a lot of the cost and the effort that they spend on, and it's almost like software is an afterthought. Like, oh, we have this hardware. We need software that can be flight qualifiable. When they hear that at least at the time that Blue was working on that, now that we have this open
Consortium
source framework, there remains to be tremendous interest by folks who build robots for space.
Awesome. Yeah, I know one company. Actually, I'm a friend of the CEO, which is called Off-Wall, which is about mining on the asteroids. So that's their plan, their mission on asteroids or other planets, but they concentrated. I don't know. You have heard of them?
I've heard of them. I don't recall if we reached out or if they reached out to us at the time. I have a huge list. I no longer have access to it. About 30 companies that we spoke to. Okay. And many of those were, space companies proper. working with either manipulators, mobility systems, even like on orbit mobility, like your like spacecraft in orbit, from satellites to others. It wasn't just robots that folks were interested in Space ROS for. It was mostly robots. You have other frameworks like F prime, which is used for a lot of satellites, and Core Flight System, which is used for spacecraft. There was an interest in how do you interface Space ROS with those so that you can reuse some of that, the messaging that's already exists, but it start exploiting some of these ROS, Space ROS type of packages. And Off-World and other organizations like that could benefit, even if they already have the beginning, like they have their foundation for their spacecraft. No, we got the interfaces. We could just plug in a manipulator that's running Space ROS, or a drill that's running Space ROS, or whatever it may be.
Yeah. Okay. Yeah. So I don't know if they are using some certified or what they are doing. I know they are using ROS in the prototypes here on Earth, but I don't know what they are planning for when they go actually to space. So if they are not using Space ROS or they are not planning to use it, then they should, because it's going to be a natural transition, right, from the tests here in ROS, regular ROS, let's say regular ROS, and then the Space ROS. It will be
Yeah, you nailed it on the head, Ricardo. I mean, that's the idea. ROS has become the lingua franca. It's a de facto standard for the robotics community, for software. That means that graduate students, when they're working on their master's or PhD theses, they're using ROS too. When they come out of school, they join a university, or ROS 1. I'm just saying ROS 2 is what Space ROS adopted. ROS, they speak ROS. So when you go to an organization and you join a company and you're all speaking ROS, that's just one hurdle that you've jumped over.
Yeah.
You can do laboratory experiments and quick prototype demonstrations using ROS. And now let's say, I want to build a manipulator for space for the Defense Innovation Unit. Well, we know how to do it with ROS too. Well, here's Space ROS. There's a very small delta between them. So you're saving a lot of cost and a lot of schedule. In fact, we estimate up to 40% cost savings when you begin using Space ROS as a reusable framework, even if you're prototyping in ROS 2. And that's based on some JPL estimates, that 40% savings. Now, if we're talking about hundreds of millions of dollars of programs, that's a significant saving. Now, all of that's going to be in software, of that cost. But it's millions or tens of millions of dollars of cost savings. That's attractive.
Yes, also that's going to help also to expand the number of companies that are dedicating, because they can afford. It's not only for just a few companies that are big companies, but other startups with less investment, and they can try some other solutions which can speed up the progress towards moving to the space.
Yeah, that's right. So you're addressing kind of the economic side of this. Right. And working at Blue Origin, there's some interest in robots, but what does Blue Origin do? They build rockets and big rocket engines. We have, Blue Origin is interested in space stations and landers, but they're really initially interested in transporting payloads to space. So now if you have more payloads that are lower cost, you have more demand for launch and transport systems. It helps fuel and perpetuate the space economy that NASA and others keep talking to. So it's just one other element of that bigger picture of a space economy. If we want to have sustainability in space, we need to bring costs down. That's the bottom line. And that was one of the key motivators of Space ROS. How do we do that? Well, look, we got ROS. It exists already. You got tens of years of hundreds and thousands of people putting effort into this framework. Why don't we just start there? Right there, that's one way to bring down the cost. So start with a well-adopted, accessible framework and start hardening it for space.
Okay, great. So we are understanding better what is about the Space ROS. Let me check my questions because we have been jumping from the conversation was following. Let me see my questions. I presume that Space ROS is based on a given ROS2 distribution. So which one it's based right now, and how are you planning to change or to keep functionality with the new distributions that appear in ROS2?
Yeah, that's a difficult question to answer, and it was a question that we had from the beginning. So we started with rolling Ridley, and really we'll start working off that. And so the Space ROS, I believe that's out there on GitHub is predicated in rolling Ridley. Now we have some ideas on how to keep up with Humble. I'll tell you, there's probably people that understand software better than me who can answer that question. So, I'd reach out to some of the folks at the Space ROS committee, because some of that's still under deliberation. The whole governance model is something that I wished we paid a little more attention to at the beginning of the Space ROS. So if we want to talk about lessons learned, there's a place that I wish we could have ended up at the end of the ACO that we just couldn't. And it's understandable that we didn't. But some of those questions, we've got some input and advice from the open source robotics folks. They work with Apex AI, who's doing something similar.
Yes, for autonomous cars.
For autonomous cars, right. So what we don't want to do, and we want to avoid, is have like some type of micro evolution where you have like wild wolves, and then also you have like domestic dogs, and they start parting ways, and then your domestic dog ends up as a tiny little weird looking chihuahua thousands of years later. And they're all still wolves in a way, but you've had this kind of this forking in the tree. Now, there is a possibility that could happen with Space ROS, but we want to prevent it. So it's a hard question. I wish I had a better answer.
Okay, no. So we want to know the state, current state. So if that's the situation, of course, not all the answers have been explained or have figured out the answer. Not all the questions have the answers figured out, but it's okay.
A challenge is resources. Like if we had unlimited resources, then we could keep up with Humble. We could keep up with the next release. But we have limited resources. So one way around that is if you have an open community, rally around Space ROS and contribute. Now, we can't guarantee that.
No, and it's not going to happen until because it's very typical in open source, until it grabs some momentum and then delivers something that has a little bit of awesomeness, and then people say, "Oh wow, that's awesome. Yeah, I also want to jump it." But at the beginning, you need to cross the chasm, which is the difficult part.
Yeah, I think you're correct. Yeah. Now, what I could say with Space ROS, one cool part of it is that you could write a piece of code that can end up in space.
Yes, that's very cool. That is very cool. Actually, I think that it is the dream of many, many robotics developers or software developers, including myself.
Right. So space becomes accessible.
Yeah.
You become a contributor to this dream of sustainability. And there's not many other areas or markets where one can do that. I mean, in open source, that's a general thing. Like, hey, Linux is on Mars, so if you contributed to Linux, you're flying on a helicopter in Mars. Awesome. And it's similar to Space ROS. We're just at an much earlier stage than Linux.
Okay. Yeah, well, I was asking you this question about the keeping with the different distributions, because that's a problem that we have here at the Construct, because we build those interactive courses, and then, of course, they get outdated because new versions appear of ROS, and then our course doesn't work. It does work, but at the previous distributions. So maybe, for example, we have some old courses that are still running in Kinetic, and they work beautiful and they are very good for what they are teaching. It's okay, not needed. But most of the courses, they need to be upgraded, and that's a lot of work because you need to do a lot of things. A lot of things have changed, especially when you are at the application layer.
Yeah, it's just a general challenge that we see.
Yeah.
It's and not just in ROS, like I was saying. I mean, if one's a Python coder,
yeah,
and they're everything at 2.7, well, hey, you're behind.
Yeah, exactly.
So it's just part of the life of being a software developer. With ROS, it's like that, but it's magnitude because of the scale of the framework. You know, it's a very large framework. Okay. So you have to have this coordination with nav2 and the next release and move it. So there's organizations dedicated to, or teams dedicated to move it, dedicated nav2 just to make sure it's keeping up with the next ROS2 release, right? And that's going to be a challenge for Space ROS.
Okay, yeah. Wanted to know if you have figured out a better solution than the one that we have.
Yeah,
I see.
I'd say it's been a conversation since the beginning, and there's different schools. There's a couple different schools that are approaching it.
Yes, I know. Okay. Yeah, the typical then discussion. Okay.
It's what one might expect.
Yeah. Okay. Then some questions we have already answered here. What about the goal for using Space ROS is for using it in robots themselves, or also for other parts or equipment of for example, let's say of the space station. So in a sense that ROS is ubiquitous around the whole space station or space habitat where the astronauts they are living.
Yeah, that's a good question. I would say in my mind, as like a dreamer, at the beginning of Space ROS, it had a lot of fantasies on where we could apply the Space ROS software framework. And that included the gambit from manipulators to mobile systems, both in surface and in space, but also other types of spacecraft, and yes, maybe even space stations. I think the reality is that we need to have specialized code for specialized purposes in order to yield some value. So, for example, there's a core flight system that NASA has. It's another open standard or framework you can get access to, which is intended for spacecraft, or let's say a lander. Like a lunar lander could use core flight system. That's what it's designed for. Yeah, one could try to solve that software problem with Space ROS, but it's a lot of heavy lifting. Space ROS is really more focused on traditional robotics, like manipulators, in space manipulators, or cranes that we go onto the moon. They have like 3 degrees of freedom, or a rover. So I think in practice, what's going to happen is that there's going to be specialized classes and solutions for different types of systems. And ROS, or Space ROS, is going to remain robotic actuators, instruments like drills. You know, if we want to drill into an asteroid, we could use Space ROS for that. But a space station would be more. Space ROS would be used in the space station to control an arm, and then we'd have an interface that can communicate through messaging with the space station's systems. Because those are, when you want to talk about safety and mission assurance, I mean, space stations, that's the real deal. Right? They go through every type of redundancy and fail-safe check that they possibly can. That's a very complicated software paradigm.
Okay. Yeah, but then listening to your explanation, it looks to me like it is so it is thought to be used on teleoperated robots rather than more autonomous robots. Is that right? My feeling?
For Space ROS?
Yes. Yes, for Space ROS.
No, we would. So there is certainly applications for autonomous robotics with Space ROS. I mean,
Like,
one of the visions was we had this framework, we had different application kits that sit on top of Space ROS. There's manipulation for teleoperated, but also autonomous manipulation. Remote navigation or autonomous navigation, and even collaboration. So if we had multiple robots that had to collaborate, we had this idea of having an application kit that would enable that. So, for example, there'd be like interaction collaborative protocols through messaging between robots on the moon, so that they could coordinate on the construction of a base.
yeah, okay.
Right. Well, that's going to require some degree of autonomy.
Mm-hmm.
Right. And same with if we're talking about manipulation far from Earth. Say we're in geo or we're in cislunar space. You're going to at least want some degree of semi-autonomy, and maybe even complete autonomy. In fact, we had some projects that we were looking at with the Defense Innovation Unit for those type of operations. It's in the open source. You can look up what Blue Origin and Motive Space Systems won this contract for the Defense Innovation Unit to mature those type of manipulative capabilities. And our role at Blue was software. It was to leverage Space ROS to mature those type of that type of manipulation software. So yeah, it's certainly within the realm of Space ROS. Otherwise, I think it almost has to be for future space.
Yes, yeah, but I see a kind of a reluctance to have autonomous robots outside, because all the ones that we have, that NASA has sent to outer space, they are teleoperated with minimum amount of autonomy. And then when I saw those projects that are going to use ROS, and for me, I love robots, but for me, robots need to be autonomous. They need to decide by themselves based on the mission that they have to accomplish. And then now I was a little bit like, I don't know if they are thinking about autonomous robot that much. That's why I was asking you.
Yeah, I mean, much like you, Ricardo, I'm a romantic, and I would love to see some autonomy in space. One thing I would say that's changing is that NASA is not making all the decisions necessarily anymore with the privatization of space. Mm. So NASA may have a certain risk posture that other organizations like SpaceX, Blue Origin, you name it, will not necessarily have. And they do not have to subscribe to the same requirements that NASA defines. So not to say that those organizations are going to mature autonomous robots, soon, but it's a different paradigm than in the past with the diversity in space. You have civil government with NASA, you have national security with the Department of Defense, you have commercial space with the type of organizations that I mentioned, and there's also a lot of like international presence in space. So there's a big diversity, and that could be a good thing, because now you have a diversity of thought and a competition of technologies and of ideas. Yeah.
Okay.
So I think that to some degree you're correct. At least initially, there is that risk posture to be teleoperated. But as we push out and want to do more and more things, if Artemis is going to be real.
Okay. Yeah, we are going to see it, I think. I think that we are in the time for that. So we'll see. With a little bit more of work, but we'll see. And then you mentioned SpaceX. So according to my knowledge, then SpaceX is not involved in the space robot operating system, right?
Yeah, they didn't have a presence, and I'm not sure what their role is, privately, but they were not part of the open source project. They're certainly welcome. We'd invite them.
Okay. Yes, I know that many people from SpaceX, they are listening to this podcast. Yes, so you are invited. You see, so here is the call, Don.
Space ROS is an open source project with an open community, so one can work for many different organizations, but the nature of open source is that we could still contribute to this open source project, independent of whom one works for, as long as it's up to their relationship with that organization. But the more experts we get contributing to Space ROS, the better.
The better. Okay. So about the SpaceX, I don't know actually. Maybe just a few of them, but about the developers, that we have many ROS developers there. So this is a call. So I'm calling you to, if you want to get your code running on space, then this is a perfect place to contribute. And you can see your code running there with your comments made by you. So this is a call for helping in the development of Space ROS. About the development, so who is in charge of the development and how is it evolving?
Right. So the Open Source Robotics Foundation is now the stewards. So we transitioned to that organization. It hasn't been affected with the recent acquisition by
Intrinsic.
Intrinsic. Yeah, Intrinsic. Thank you. So it's still going, still under the stewardship of open source. They have helped stood up an initial committee, and there's some of the folks from the type of organizations like Picnic and Emergent Space, SWIRI, myself. There's a lot of the old band that's still part of Space ROS. So that's good. There's some continuity and leadership and contributions.
Okay.
We're in the very beginning of that transition. We're setting up some meetings to have some discussions amongst key stakeholders and decision makers on how we want to, as a team, agree on how to approach, a Space ROS and make sure we keep the flywheel spinning. It has some interest, it has some momentum. Let's keep it going.
Okay.
Still a lot of interest from NASA and a lot of conversations with NASA as well.
So is NASA is contributing also?
NASA is more like consulting.
Consulting.
Yeah.
Okay.
Yeah. So again, we want to have that continuation of ideas and the folks that helped formulate Space ROS from the beginning to be involved as much as possible. But the idea is that it's still going to be a transition organizationally to an open community, to an open body.
Okay. And then you mentioned about your transition from, because we mentioned at the beginning, you were working for Blue Origin, but now you are working for another organization which is called Peraton, right? So, but then Peraton is nothing related to space ROS, right? It's something...
Yeah, not to Space ROS, but Peraton has a presence in space.
Okay.
And we have several contracts and programs for space capabilities, mostly in communications, out in space. But yes, with the transition, so Peraton's it's a national security firm. It is information technology, some mission capability integration. And my role there, as you mentioned, is with like AI autonomy. We do some robotics for test beds of things that we're maturing. But independent from being a Peraton, I'm on the Space ROS Technical Steering Committee. And I have a role contributing to Space ROS. It's not Peraton contributing. It's me.
It's you, yeah. And you are one of the leaders that launched this Space ROS project at the beginning.
Yeah, that's right. So if we go back to the beginning, I joined Blue Origin. I was asked to start some programs that are going to help with the sustainability in space, bringing the cost of not just robots, of in space presence down. And so I thought, in my prior days at Northrop Grumman, which is a defense firm, I used a lot of ROS. And the defense community uses a lot of ROS in prototyping, and they have ROS military, right? There's a ROS industry, or industrial ROS. And I thought, well, what about Space ROS? Like, there has to be a need for a similar framework that's reusable, modular, accessible, can bring the cost of software down for space. And so I started asking around, and I got introduced to Terry Fong at NASA,
Yes.
the great roboticist at NASA. And he says, well, you know what? We've been thinking about that also. But what we have not had is advocacy from the commercial side. So they had an internal desire, but they couldn't quite push the rock up the hill without having additional support from commercial. But I said, well, that's great. You know, who else can we speak to at NASA so that we could set up a program going after this ACO that I was referring to before? That was the motivation. The ACO came out. I tried to pull together a team. In fact, I did, so that we could respond to that ACO. And what we responded with was Space ROS. So yeah, ROS had been used in space before. There'd been a desire to take ROS and mature it so it could be used on higher risk missions. And here I came along and said, hey, I'm interested in that also. And that was the genesis of Space ROS. And I didn't call it ROS-space. I wanted to call it space with a space and then ROS. So we have Space ROS. So if you write Space ROS without a space, you're not writing it correctly. There's a space in between space and space.
Okay.
I'm the one who did that, so I can vouch for it.
Okay.
So that was the origin. That's how we married up with NASA on this 2-year project.
Okay. Great. Good story. So now, even we didn't hear at the beginning of this interview, but now we have all the whole story from the beginning, also the current situation and the goals of Space ROS and the current situation, of course. Then, what about, so you mentioned that it's open source. So, and I will put a link to all the places that you have mentioned, where the GitHub and also the spaceros.org website that you mentioned. And what about simulations for testing Space ROS code? So how can we start using Space ROS in order to create, let's say, very simple application, talk and chatter, and then testing using Space ROS?
Yeah, so on the GitHub, there are a couple simulations with a Martian rover, I think it's Curiosity, and a Canadarm. And those were simulated in Gazebo. So that was actually...
We did it. Yes,
you did that?
We did it, yeah.
Oh, you really?
Yes, we put everything together. We took the models from the NASA, whatever, and then we put it together into a Gazebo simulation with the controllers, and then you can launch the arm and the...
Is that what's on our GitHub?
Yes.
Oh, awesome.
Oh,
okay.
well, I don't know if it is the one that is on your GitHub, but...
It's probably very similar in principle regardless.
Yeah.
Right. So the point there is that we're using Gazebo, RViz, Gazebo packages. This was a subject at the beginning of Space ROS 2 years ago. How much do we invest in the simulation environment versus the software maturation of the Space ROS framework itself? And we had finite funds, so there was only so much we could do. So we made a decision. As much as I wanted to mature out a cool, sexy, simulation environment and visualization environment, we invested the funds into that iceberg model and maturing out our continuous qualification infrastructure and the tooling to check for software quality. And the desire has always been, all right, now let's pivot and have some space relevant simulation type of environment. We could still use Gazebo, and we use Gazebo for a lot of what we did in simulation even for some programs we had. So it was quite relevant. The trick starts becoming with physics when you have things like contact dynamics in space. I think in a show in the past, someone mentioned that. You touch something in space, it's gonna, you're not in a gravitational field. We may need more than a Gazebo physics engine to capture that. So I'll just name some of the problems and the challenges that a future simulation environment might have to contend with. Traction on the moon in regolith is very different than traction on the Earth, on pavement with rubber tires. So there's a lot of challenging physics that needs to be demonstrated. And why is that important? Well, if one's navigating or localizing, we need to understand some of that slippage.
Yes.
We need to understand the sensor information that's coming into a common filter or whatever, the approach that one's using for localization or for pose estimation, especially if one wants to be autonomous. That's how we're going to get around the need to be teleoperated. Because right now, you make a move, you wait 3 seconds if you're talking to the moon, right? Because that's the delay.
Okay. Now I got it. Okay.
So now, if we have some of the physics that we could simulate more realistically, that gets us one step closer to semi-autonomy, so that the control loop will be different between communication or controlling a robot on the moon. We took a look at some like NVIDIA Isaac and some other platforms as well. But so that's the current state of simulation right now. It's user's choice.
Okay. Yeah, I know that Open Robotics created with NASA one simulation about a lunar rover some years ago. They never released it to the public. I'm just letting you know, just in case that you can talk to those guys and let you use it, because I think that they created very tricky plugins and add-ons that are not available to the public and that are specific for those kinds of things, also including the sensors, so the cameras, how they are getting affected by the light, because the flare is different there, and I don't know exactly the details about that, but I know about the shades also. They are affecting a lot to the detection of the environment if you are vision based. And I don't know. Do you know about that simulation?
That's good to know. I don't know if I know of that one. I've heard of several simulations that exist that have been done and have been worked on for various missions. And some that we looked at, I'm not going to remember names. We deemed as like it'd just be too much heavy lifting to try to mature it into something that's accessible to the open source. Right?
I see. I understand. Just sharing some information just in case that is relevant in the future.
The plugins could be quite relevant.
Yeah.
So right.
Okay. Then those they are not available as open source. So
I'm just not aware of it. Maybe they are.
So they presented this lunar simulation in a ROSCON, and it looked amazing, very, very nice. Even they were putting also the tracks of the rover as it moves along the way on top of the moon. Then it's leaving, the sand is leaving these tracks of the wheels. So that plugin was able to include those things also. So then later when the robot comes back, so the environment has been modified by its movement along it.
Yeah, that's pretty impressive. Was that for Viper or was that for a different mission?
I think it's before Viper.
Before Viper. Okay.
Before.
So that's like the nature of NASA. There's a lot of software that NASA's worked on in the past for various missions, and sometimes it's just a matter of knowing it exists.
Okay. Then I don't know much about that. Then what else? So I have one question here, but I don't know. So if there is any plan to launch a robot to space running Space ROS, so when is there any plan to know when are we going to have that?
Yeah, so I'm not sure of a mission that's planned like currently. There are missions that have discussed the use of Space ROS. And there's some programs that we've worked on. When I was at Blue Origin, with partners for customers to begin maturing software for missions. But those missions were still many years in the future. So it was at the beginning of those programs.
But that's
So
cool because it's allowing to have time for developing what is needed.
Yeah, and what's encouraging is that we went to a customer, a government customer, and said, "Here's our solution, and it includes Space ROS," and they awarded a contract. So there's an interest, and there is an investment by not just an open source community, but financial investment from customers who want to use Space ROS as part of a solution for a very valuable robotic system that would go in space. Now, that's the government. Contracting is a strange world, and it could start off as you're in one organization working on a program, and there's a completely different organization that's the end user, and the path. I don't know what Dijkstra's path is or A star, how you get from here to here. Sometimes that's uncertain, right?
Yes.
But what's encouraging is that there's that initial interest. I do not know of a specific robotic program right now that has a defined date for putting across in space.
Okay, but we know that there is a current situation and that there are some possible missions that can use it, and then there is a theoretical path between the current situation to those goals. So maybe
there's a theoretical path, but we don't know what the configuration is.
Yeah, exactly.
I couldn't tell you what it was. But I have a lot of confidence in Space ROS. I felt, and maybe it was just an arbitrary number, but I thought in 10 years, it could become a de facto standard for robotics.
In space, I hope.
Space robotic software in space. For space, robotic, and autonomous systems in space.
I hope so.
What I mean by that is that it's matured to a point that it's reusable, or even organizations have taken a private port, because you can port it privately and have a proprietary port of it, so that it's being used for their robotic systems.
Well, that's another option, because that would be the similar path as Apex AI has followed, right?
So there's nothing preventing. I mean, it's the Berkeley license, right? Mm-hmm. It's within the scope of that license to take a port of Space ROS or ROS 2, or whatever, and build proprietary software, and that's a nice thing.
Yeah,
that's a very attractive thing.
Yeah. Okay. Then, So a couple of questions more, and then we are done. So about your secret plans for the future of a Space ROS.
Yeah, my secret plans will remain secret, right? They have to.
The secret means that you wouldn't say to anybody, only to you. And here we are in confidentiality, so we are just you and us. Right? Yeah, 1-to-1. And then, so what can you tell me about your secret plans?
So my plan for Space ROS is to ensure that it happens. If this may not be as exciting as a secret, but I'm attached to Space ROS, and the people who've worked on Space ROS, there have been quite a few, are vested in it. We spent time and sweat and hours and lack of sleep working on this framework, and it's super exciting. It's one of the funnest projects I've ever worked on. It's probably one that I'm the most proud of, because it has such a promise of being perpetual. Yeah, it's almost like raising a child. You send them to college, right?
Uh-huh.
That's what it feels like with Space ROS when you start from the beginning of its infancy, and we get it to a point now. You're kind of like graduating it to some level of education where it's going to mature even more, right? So my not so secret is to remain involved in the process and help rally a team of contributors around the Space ROS name that to help carry that banner. I think it's very important, if we're serious about space, that Space ROS remains.
Okay, one option that can help this, one suggestion, is maybe to do a workshop about the Space ROS at the ROSCon this year, because this year is in the States, so it's easier for you also. You are from the States, and then so maybe do this kind of of workshop can help attract the technician and also developers on that project?
Yeah, I agree with that. And we've been slowly increasing our presence at ROSCON. Kim Hambuchen is how it's spelled, from NASA gave the keynote speech 2 years ago, the opening.
Yes.
At ROSCON?
Yes, at ROSCON, yeah.
Yeah, and so that was our first public announcement of Space ROS. And I believe in Tokyo, or in Kyoto this year, there was, although I wasn't there was some Space ROS presence. I don't know if it was a workshop proper, but there was some,
it wasn't, I think it wasn't. I was there.
Okay.
I don't remember a workshop. It rings me a bell about a talk, but I don't know because I couldn't attend. I was doing some business and things like that, so I didn't attend. We have our own booth there. But it rings me a bell, so I think that maybe, yes, there was some talk about that.
So it makes sense. So that's really just an awareness campaign as we get through the 2 years of the ACO before we make the transition to an open source steward. And so, I agree. I think it would makes a lot of sense to have a workshop.
Yeah. Okay. And then final question. So we already talked a little bit about the intrinsic having acquired the Open Source Robotics Corporation. And then, so taking a lot of the workforce from Open Robotics. And then how is your opinion? So what is your opinion about that, and how is that affecting, in your opinion, to the development of the Space ROS project?
Yeah, so far I haven't noticed an effect. And as I mentioned before, there's a lot of the old band that's still sticking around for Space ROS, and that includes folks who are now at Intrinsic, who are going to be on the steering committee and helping guide and do some development. So at this juncture, I haven't really noticed an effect, and we'll see what happens. I think regardless, what's important is that we get a solid steering committee and governing body, and we have a governing a clear definition of how we want to govern Space ROS and get community contributions, and then execute on that. So it's not, we're not going to be able to do it alone. We're going to need contributors from the open community, regardless. Regardless of if the intrinsic acquisition hadn't happened.
Yeah. That's right.
So I think we're at the same place either way.
Okay. Just a few folks that are more stressed right now, the ones that at Intrinsic, because they have to be dealing with intrinsic things and also helping on this project. But
there's a potentiality of that.
Okay. But in the long run, that's just a drop in the project. Because
I think that's just what happens.
Yeah. Okay.
It's like if one's worked on open source before or these type of projects, it's not a clear path. It's a lot of being agile and adapting to opportunity or to change.
Great. Excellent. Well, those are all my questions for today. Thank you very much, Will, for coming here and explaining all the situation about the Space ROS. Thank you.
Yeah, thanks for having me, Ricardo. I appreciate the invitation.
My pleasure. And then, okay, so for the audience, that's all for today. Remember to rate this podcast on wherever you are listening to it. For example, on Spotify, on Apple Podcast, Stitcher, whatever, Google apps. And also send me some feedback, guys. Send me some email telling me what do you think, what you would like to have, what do I have to change. I don't like the music. I don't like whatever, the background. Tell me so we can improve this podcast, because we want to make this podcast for you. Well, that's all for today. See you next week with another lesson from the experts. And until then, keep pushing your ROS learning.